Hello everyone, welcome to my YouTube channel Tech with Ankush again. So today I will create a theory on like what is a Azure Load Balancer. So Azure Load Balancer is an Azure service that allows you to evenly distribute incoming traffic, network traffic across a group of Azure VMs or across instances in a virtual machine scale set. Load balancer delivers high availability and network performance in the following ways. Number one, load balancing rules determine how traffic is distributed to instances that comprise the backend. Health probes ensures the resources in the backend are healthy and that traffic isn't directed to unhealthy backend instances. So overall means load balancer actually it is like a Azure service. It it controls the flow towards the virtual machine. Like if a user will send if the lot of users will send so many requests, so load balancer evenly distribute the traffic across the virtual machines or virtual machine scale set. And and it will like it will- the, so it will like determine like how so first point, it will determine how the traffic let me So it will determine how traffic is distributed to the instances that comprise the backend. Also, it will use the health probe to ensure the backend are healthy and traffic isn't directed to unhealthy backend instances. So let me explain you how does it work. So like if we have request from users, okay, lot of requests like 1, 2, 3, 4, then 5, 6, 7. Like we have 7 requests from the different users. So what your load balancer will do? It will this request, first request, it will send to VM1. Then second request, it will send to VM2. Then third VM3. Then fourth here. Then 5. Then 6. And this one, the last one, it will go here. So in this way, the traffic is distributed across the virtual machine or instances. And second, health probe. There is also one more feature as your load balancer have, that is health probe. Health probe means if there is something wrong with the virtual machine, then the load balancer will redirect the traffic from that virtual machine to the other virtual machines which are in the good state. Okay, I will explain all the things in detail after some time. So let me first explain this thing. So now if like there is like 7 requests, so 1, 2, 3, 4, 5, 6, 7 requests from users. And on the meanwhile, let us assume this virtual machine is not in good state. Okay. So what this load balancer will do, it will, due to this health pro feature, the load balancer will get to know that like this virtual machine is not in good state. So it will transfer the request one here, second here, then third, fourth, fifth, sixth, and seventh. So in this way, it will also ensure the resources in the backend are healthy and the traffic isn't directed to unhealthy backend instances. So load balancer ignore this virtual machine and it will redirect the traffic to these virtual machines. So now in Azure, there are two type of load balancers: public load balancer and internal, or we can say private load balancer. So public load balancer means for traffic from the internet, and internal load balancer means for traffic inside your private network. So let us come to public load balancer. So think of it as the front door of our application. It take request from people on the internet. Like when someone opens our website, it uses a public IP address visible to everyone online. How it works? Map public IP plus port what user type like www myapp.com 60 to private port to private IP plus port of the server inside Azure. Example, 100 people open our website. The load balancers spread those requests across several web servers, so none of them get overloaded. So let me explain you in detail. In public load balancer, it only works on the like public side, or we can say on the internet. It take request from the users on the internet, and what does it use? It use the public IP address plus it use the port number. So what does it do if a user sends like if a user open up a like application or any website www.google.com and the port is 80, then the all the traffic will go to this load balancer, and this load balancer will distribute the traffic across the web servers which is inside the Azure. And there is one more extra feature. It also lets our VMs make outbound connection to the internet. Like when our VM needs to download updates or call an API, means it will also accept the request from users and send it to send the request to virtual machines like or web servers, we can say. Also, if VM wants to talk with the internet or public internet, then it will also redirect the traffic to the internet. So it will also do that. Means like if a VM wants to update their want to do Windows update or any software update, so it will also help the VMs to talk with the internet or API or call an API. Means like we are using a weather channel, like we are using a weather app, and we wants and the virtual machine wants to know the exact temperature of a particular place, so it will talk to the website which is providing the weather update, and it will update at their end also. So load balancer helps the users to communicate with load balancer uh, distribute the traffic or maintain the traffic from users to virtual machine. Also, it will help the virtual machine to make outbound connections to the internet. So now comes the internal load balancer. So it is used to distribute traffic inside a private network. Its IP address is private, so it cannot be accessed directly from the internet. It only works within Azure Virtual Networks or through a VPN that connects your on-premises network to Azure. Means the internal load balancer it resides in the virtual network. It is not exposed to internet. Okay, so it is not visible for users or any other person directly from the public place or internet. And also it also like it works with Azure virtual networks, or like it is also works it also connects with the on premises servers using VPN. So there is a separate connection using a VPN. Like on premises servers will get connected with these servers, servers in the cloud using VPN. And then in that case, we will also use internal load balancer. And they all and the connection, it is not exposed to internet. So the difference between public load balancer and internal load balancer is that public load balancer it is exposed to internet, and in the internal load balancer it is not exposed to internet. So now what can an internal load balancer do? It allows different type of load balancing inside a private network not exposed to the internet. Here are the main cases. Number one, within a virtual network, it balances traffic between virtual machines that are inside the same virtual network. Example, if we have 5 backend servers in the same virtual network, internal load balancer distributes traffic from one VM to all other, so no single VM gets overloaded. Means the first point, it will work inside the within the virtual network. Means uh, the load balancer, it works within the virtual network. So it is not exposed to internet. Like if there are 10 servers and the request has been, so like if there are 20 requests, so load balancer will divide 20 requests, like two requests to all servers. Then on then for a all cross premises virtual network, it balance traffic from your own premises computers, your office network, to Azure virtual machine inside a virtual network. Example, your office users connect to Azure through a VPN. Internet load balancer ensures their requests are separate across multiple Azure's VMs fairly. Means it is also used for a on premises or on premises, like it will also help to connect on premises network to Azure virtual network. So it will also work in this way. So here the internal load balancer will work like this is our on premises network, and a user wants to connect, or or a machine wants to connect with this uh, like virtual machine which is inside the virtual network. So it is connected through VPN. It is not exposed to internet. So here the internal load balancer will also work. So now it is also used for multi-tier applications. Like many applications have layers like front-end tier, internet facing like a website, back-end tier, not internet facing like database or processing servers. Internet load balancer is used to balance traffic between these private back-end tiers. Example, a web app receive request from a user via public load balancer, then sends heavy tasks to backend VMs via an internal load balancer. So let me explain you how does it work. So here, mm, so like this, these are the users. They want to connect with. They want to open up a website. So all the requests, like three users, they send the request. So here there is a public load balancer, and it will distribute the traffic across these VMs. And from these VMs, if there is a requirement, other requirement for like for database access and other requests, so these VMs, it will send the traffic to internal load balancer, and this internal load balancer will distribute the traffic. Like here, one will go here, the other will go here, then here and here. So this internal load balancer, it is not exposed to internet or public. It is inside the network. Okay, and this public load balancer, it is exposed to internet. So I can say internet. So here, this is the way how the public and internal load balancer will work. Now, internal load balancer, it is also used for uh, we can say line of business applications. Like example, like LOB apps are internal company apps like HR, payroll, finance or reporting system. These apps run in Azure but are not in the on the internet. Internet load balancer helps balance traffic for these apps without needing extra hardware or software. Load balancer even on premises servers can be included in the load balance set. Means like for LOB applications, like now business applications, we will also use internal load balancer. It transfers the traffic internally and without need of any extra hardware. Plus it will also help the on premises servers can be also connected with these uh, Azure virtual machines. Like let me give you an example. So like these four users want uh, so like these four users want to access these apps. Like there is a CRM which only works in the uh, which only works on the on premises. Okay, and the on premises server, it is also connected with Azure portal, or we can say Azure. So like the on-prem there, so they like we will assume there are servers inside the on-premises network, plus there are servers which these on-premises servers are also connected with the Azure servers. So like if users want to open their CRM or any other application, so so how it will work? It will open up the application. So on their system, and all these requests will then get transferred to internal load balancer, and this internal load balancer will check whether these requests are from the internal servers, or the request will so it requires the servers which is on the cloud, so it will automatically redistribute the traffic. So this is how the internal load balancer will work to connect on premises network and Azure virtual network servers. So now comes like how load balancer works. So load balancer have several elements that works together to ensure an application high availability and performance. And the load balancer, it works on layer 4, okay, of the OSI model. And these are the elements which all are included to make the better functioning of load balancer. So it includes front end IP, load balancer rules, backend pool, health probes, inbound net traffics, high availability ports, outbound ports. So front end IP. So for public load balancer, the front end IP is like the public IP. Like if a user types the website www.google.com, so during if the user type this website, so it means the user is typing the website plus port. So what does load balancer will do? It will accept all the requests from the users and distribute the traffic to the VMs which are under the Azure network. Okay. And also if the VM wants to talk with internet for any API or for an updates, it will also helps the VMs to talk with the internet. And opposite of public load balancer, internal load balancer, what does it do? It only works inside the virtual network, and it takes the traffic from the web servers or like inside servers and distribute the traffic to the other servers, or we can say database servers. And in this case it is not exposed to internet. So let me explain you how does it work. So so now I will give you a complete scenario about how the load balancer, internal and public load balancer, will work together. So if a user, like if there are five users and all have typed www.amazon.in. So right now five users, they are trying to access Amazon website. So but they all the request will go to here public load balancer. So if we type www.amazon.com, there is also a port like HTTP or like 80 or 443. So it depends. So this is the website, and the DNS server, it will automatically transfer, like it will check like where it has to be transferred. So it will transfer the request to the virtual network, okay, or to the web servers which is associated with this website. So before these web servers, there is a we have install or we have used the public load balancer. So the request will first come here, like these five users, they will get connected with this uh, public load balancer, and this public load balancer then check the request, and then it will distribute the traffic, like if to these servers. Like in case if this server is not working good, then it will distribute the traffic to these two only. So currently we are assuming that all the three servers are working fine, so it will distribute the traffic in this way. And if these VMs require to connect with internal servers, other servers like database servers or business tier servers. So these VMs will send the request to internal load balancer, and then in internal load balancer will check where it the traffic has to be sent. So it will distribute the traffic in this way. So this is the complete working of public and internal load balancer together, and we can see it is not exposed to internet. Okay, so I can say not exposed to internet, but this is exposed to public or internet. So because these users they know the IP address, they know the website name or and the port. So this public load balancer it is exposed to internet, but this internal load balancer it is not exposed to internet. So this is the working of internal and public load balancers together. So now comes load balancer rules. A load balancer rules define how traffic is distributed to the backend pool. The rule map a given front-end IP and port combination to a set of back-end IP address and port combination. So traffic is managed using a 5-tuple hash made from the client's pins. Like in the load balancer rule, it requires the source IP, like who is connecting to the IP address of the requesting client, then source IP, the port of the requesting client, the destination IP of the request, like where the traffic has to be sent, destination port also, like on which port the traffic has to be sent, then protocol type, like whether load balancer is using TCP or UDP because it works on the layer 4. Then session affinity means if a session affinity means like if a user is connected with virtual machine 1, and if he goes disconnected, if he tries to connect again, so there is a time limit. So if he will try to connect again, so the load balancer will send the traffic to the same of that user to the same virtual machine. And load balancer. Now backend pool. Regarding the backend pool, pool means like the number of virtual machines or web servers or business tier servers which are working in the Azure virtual network. So like if we have 10 like if we have 10 web servers, and due to due to increase of the traffic, we are using VMSS virtual machine scale set. Means like if we have increased the virtual machines like from 10 to 15, then load balancer will automatically reconfigure its roles to other 5 machines also, and it will distribute the traffic to all these 15 virtual machines. Now health probes. So health probe means like Azure also use this feature, like if there is the load balancer also use this feature. If there is something wrong with the virtual machine or servers, then it will not send the traffic to that server. And if there is a existing connection, so it follows this rule, like the connection remains until the application ends the flow. Means the application automatically gets terminated, or the idle timeout occurs. Like if there is a idle timeout for 2 minutes, then after 2 minutes the this load balancer will stop the traffic, or the VM shuts down. If the VM shut down by itself, then the load balancer will not will the session will remain till that time. And it uses these health probe load balancer allow you to configure different health probe types for endpoints using like TCP, HTTP, or HTTPS. TCP custom probe. This probes relies on establishing a successful TCP session to a defined probe port. If the specified listener on the VM exists, the probe succeeds. If the connection is refused, the probe fails. You can specify the port interval and unhealthy threshold. In TCP custom probe, Like these are the we can say custom probes we can use. Like we can use TCP or we can use HTTP and HTTPS for health probes. The load balancer has these three features. Like for TCP, it builds a TCP connection to with the virtual machine, and if the load balancer know uh, the health of that virtual machine is good, then it will send the traffic. If it doesn't get the if there is something wrong with the connection, then it will not send the traffic. Then comes HTTP or HTTPS custom probe. The load balancer regularly probes your endpoint after 15 seconds by default. The instances is healthy if it's respond within the HTTP 200 within the timeout period default of 31 seconds. Any other status any status other than HTTP 200 cause the probe to fail. You can specify the port, the URI of requesting the health status from the backend URI, amount of time between probe attempts, and the number of failures that must occur for the instance to be continued unhealthy or unhealthy threshold. So let me explain you in detail. So for HTTPS, like custom probe, what does the Azure Load Balancer do? It will send the request to VM1, then be like all the VMs which is connected. And so if the like this request will send after 15 seconds, this is by default. We can change it to 30 seconds, 20 seconds. It depends upon us. And if we get a response from virtual machine for HTTP, like yes, HTTP, like if we get just a sec. So if we get a response like HTTP 200, it means like it is fine. So then the virtual machine will send the traffic to this VM. Otherwise it will not send the traffic. And like if the virtual machine send this response to load balancer, so then the Azure load balancer will send traffic to this virtual machine. And like for virtual machine, Azure load balancer check the health probe, like it send the request, but it get the response like HTTP 500 error. So in this case, load balancer didn't get this response like HTTP 200. It gets this response like 500 error. So in this case, the Azure load balancer will not send the traffic. It receives the different response. So it will not send the traffic to this virtual machine. And same like if we a load balancer try to connect with this VM3, like it sends the request like HTTP 80, and in the return the load balancer waiting for this response HTTP 200, but instead of this one, it will the load balancer get the response like error HTTP like 300, then or it doesn't get any response. Okay, or we can say no response, nothing. So no any HTTP error or nothing. So here like Azure was this load balancer was expecting this response, but it didn't get response. It gets nothing, no response. So here the load balancer will not send traffic to this one also. So in this case, Azure load balancer, yeah, it founds that this VM is not good. Also, this is not good, and it will only send the traffic to this virtual machine, and it will ignore the other virtual machines. Now comes the session persistence. Persistence, we can also known as session affinity, source IP affinity, or client IP affinity. So we have like three options. Like we can use none. In this case, like if there is a like if there is a communication going from a client, it will send the request to any virtual machine. Then client IP two tuple. Like here it uses the IP address. Like if a client is talking with the like if a client is opening up a website, and like if a client the request is connected to VM1, So it only uses the IP address of the client and virtual machine, and both will get communicated, and both will get connected to a particular interval of time to the same virtual machine. And there is also like three tuple. It uses the it uses like IP address plus protocol combination. So these are the three features. Then availability port, like we have configured a load balancer, and we have configured protocol, like it will accept all protocol plus port 0, means high availability port rule. So in this case, the decision is made using these five things, like five tuple, like source IP address, source port, destination port, and the protocol. So it works in this way. Then inbound net rules. There is one more rule, like inbound NAT rules. Load balancer also uses the NAT rule, like network and address rule. Like here, it will we will use this rule for a TCP connection. Plus, it uses the port number. Then outbound rules. So for outbound rule, the this load balancer uses the source network address translation rule. Okay, like if a VM wants to talk with the internet, then it will use the SNET rule, means source network address translation. Like if any VM which wants to talk with the internet and it requires the update, so it will talk with the load balancer and it will say the VM, like load balancer, that I needs to update my system or do Windows update or any application updates or any core. It wants to call an API, means it wants to take the uh, information from the internet. So in this case, load balancer will also help the VM to talk with the internet. So now comes the last part, like when we have to use load balancer. Like load balancer, it's like a high performance, ultra low latency layer 4, like it works on layer 4 inbound and outbound for all UDP and TCP protocols. It builds to handle million of requests per second while ensuring your solution is highly available. Azure Load Balancer is zone redundant, ensuring high availability across availability zones. So means like if we use the TCP or UDP protocol plus we needs to work on layer 4, then we will use load balancer. Like if we needs the like if we need higher security, like for web applications, then we do not use load balancer, because the for that applications the applications works on layer 7 of the OSI model. But if we need only a TCP and UDP connections, then we will use load balancer because it has high performance and high availability. So that is why we can use load balancer. So that's the end for the for today's session. This is the complete theory of load balancer. And tomorrow I will create a lab on how load balancer will work, and I will create a practical for you. Like I will create two practicals. One is for internal load balancer and one is for public load balancer. Thank you and have a good day.